Um, Thank you very much, everyone, for being here. I'm going to say right off, I'm very humbled that everyone that's in attendance right now. There are colleagues that I'm working with right now, and then there's colleagues that date back to 40 years. So thank you all for being here. Hopefully, I don't bore you too much, and let's get into it. First, this is the outline of what I want to talk about. I was just going to give a little bit of context before we get into it. And I've kind of broken it into a couple of sections. One, I thought the simplest way to do it was sort of to go through time in some steps that were meaningful in my career. And then there are some specific technologies I'd like to elaborate on a little bit more. Some thoughts on where I think the future's going, and then I'm going to close it out with some other closing thoughts. So gone through all that, and just let's be perfectly clear, I'm not a historian. So this is just observations that I've seen over 40 years, and others may have a completely different experience because they viewed it from a different perspective. I'm mostly a pipeline, permafrost, geohazards kind of guy, and if you were a foundation engineer, you'd see things completely differently. And just to preface, if you're looking for a very technical talk, I'm sorry to disappoint, but it isn't like that. It's more about, if it seems less about geotechnical engineering and just more about how society's changed, which has influenced it, that's probably pretty accurate. And as Jack Black said, this is not the greatest song in the world. This is just a tribute. So this will be pretty pale compared to what probably happened. Let's break it down. So the beginning. So early on, in sort of the 81 to 83 period, just to put it into context, the reports were all handwritten. Like we would have secretaries, we would call them then. I mean, they were really professional typists. Would type your report generally like on an IBM selector or something like that. The first few years, word processors didn't exist. I mean, they sort of get phased in towards the end of this period, but at the beginning they weren't. So let's be honest, you didn't want to make a lot of changes to your reports. So, if excessive edits were frowned upon because that required retyping entire pages, maybe even the entire report. Like the carpenters would say, measure twice, cut once. And cut and paste had a completely literal meaning here, where we would take a good paragraph from an old report, cut it out, and then with Scotch tape or staples, put it on, cut it onto a page, and then add a few more words in the margins there. And whiteout was your friend when you couldn't spell correctly. Continuing on, photocopiers are large and bulky and poor quality black and white prints. Telephones were on everybody's desk, more or less, unless you were an EIT, and then you often shared a phone in a pool, and that was always an interesting experience because some people were on the phone all the time, other people never got a call, and no one had a direct line in those days. It was all patched through a receptionist. So at the beginning we had telecopiers, not a fax machine. It literally was you'd put a piece of paper on a drum and it would spin for 2 or 3 minutes to transmit one page. We did have a strange device called a telex, which is sort of a cross between, I guess, like a telegraph and a text message. That's what it looked like. There was sort of this ticker tape thing on the left-hand side there that had some punch marks in it. Theoretically, I guess that was the message that would be typed out on that archaic-looking typewriter thing. So in this time period, computers really came in two flavors. You either were working on a mainframe computer. Where I worked, we had a real workhorse for the period that probably lasted over a decade or maybe even 2 decades was the digital PDP 1170. But whenever we had to do something more sophisticated like a major settlement analysis or something like that, or anything 3D, you would be buying time on a commercial mainframe computer downtown Calgary usually, and it'd be either on a VAX, and I think that Stardyne was the other company that we were using. And if you were very lucky, you might have access to a specialized mini computer for a particular project. Through this time period, commercial software was extremely limited, and programs were generally written by engineers in either BASIC or Fortran, and the programs we were writing in those days were thaw settlement programs, slope stability, etc. Had the privilege of sitting with Mark Nixon, and I used to work with Mark's dad, Derek, and Derek used to have several programs that he'd written unfortunately in Fortran, which is not my favorite, but very sophisticated, and they probably lasted for a good 3 decades. Storage in those days was on mag tapes, and which had a completely different context. I mean, when nowadays, if you're a Linux fan or something, you know, there's commands like mount still. Well, in those days, when you typed mount such and such a tape on such and such a device, literally you're sending a message to someone downtown Calgary to go grab your mag tape out of storage and then physically mount it on a drive so you could use it. Interfacing with the mainframe computers was also interesting. You had basically 2 options. You either had a very dumb cathode ray tube terminal, which is really like a television with a keyboard attached, or the less preferred deck writer, which was basically just a printer with a continuous feed of perforated paper and a keyboard, no monitor. So the PDP 1170 is in the middle. The dumb CRT terminal is on the right-hand side, and then the left is the infamous deck writer. And I spent way too much time in front of a deck writer, where literally you type out your command, it would echo it back, and then hopefully the computer on the other end would respond and give you what you wanted. I mentioned some of the special projects would have a mini computer. This was an HP that we were using on the Foothills Pipeline project. And this is where we did all our thaw settlement, and we would have things called borehole databanks, which were really just ASCII files. But you know, we wrote this paper, I think back in, well, we did the work probably 82. The paper I think is from the Permafrost conference in 83. So I love some of the words here. We talk about we had a computerized borehole databank. Ooh, that was pretty impressive. And then we did things on a computerized thaw settlement program. So which was some kind of unique basic to Hewlett-Packard. And there's the flow chart if anybody cares, which is a long time ago. So then between 83 and 85, I went to Fort McMurray. I was talking to some people and just saying, yeah, we had a bit of a recession, a little bit of a downturn in the economy, if anyone was around in that period of time. And so I was out of the office, or certainly out of the big cities in those days. I was in Fort McMurray, and what computers? I mean, there is no computers anywhere to be had. But it's not to say we weren't without technology. I was mostly in the Syncrude mine, and they were cutting edge in terms of slope inclinometers and piezometers and things like that. So in those days, the industry was dominated by Synco, which is the slope inclinometer company out of Seattle, and they were the original developers of the technology. The casing hasn't changed a bit, guys. I mean, what you're using today is exactly the same. The only thing that changes a little bit from company to company is the couplers. I guess that turns out you can't patent grooves in a plastic pipe, but you can couplers. The sensors were really bulky, making the probes big. Some of them had a huge bulbous end on them. The cables were phenomenally heavy. They had steel inside and big wires, so they were painful to carry around. And the readouts would range from having absolutely no storage, and the very early ones that I worked on actually had Pixie tubes. If anybody knows what a Pixie tube is, go Google it afterwards. It's pre-LED, put it that way, or LCD. But again, Syncrude being very cutting edge at the time, we were introduced something called the RPP, which was a recorder printer processor, which was a gigantic box. I think it had a mag tape on it as well. And so the readings would be recorded onto this device, and it would print off movement on a horrible little thermal paper. It was silver in color, and it was, it got holes punched in it by an electrostatic shock, or spark, pardon me. In this era too, we put a lot of piezometers in, no vibrating wires. These are all pneumatic, and anyone who's worked with pneumatic piezometers know they work good for a while, but then they tend to give up the ghost for various reasons, being very mechanical. Yeah, that's me in '83. So and that's standard PPE. Like I'm not cheating or anything. Glasses are not required in those days. I do have a UHF radio there. I think I got a groovy mic over here. I was pretty cool kid. Moving on, 85 to 86. Okay, so this is when we started to see PCs entering the consulting field. And I say there was usually 1 or 2 machines per office. That's not because companies were cheap. They would literally probably cost $4,000 in that era. Incredibly expensive. But what it did allow us to do is to start to work with commercial software. And this whole revolution of you owning software or you being able to do the work on your own computers was quite freeing at the time, because the mainframes were very limited and there was a move away from that. Yeah, they're pretty modest in terms of their operating systems. Were like DOS 3.0 or something like that, or even earlier. Very few had hard drives. If they did, they were just incredibly small. Most of the time you were running with dual floppy drives. We did, in this time period, GeoSlope did come out with a very nice slope stability program in those days. Actually, CPG as well. And John Cron was a key developer through all that time. Hats off to him. It was a great product and continues to be that in its present carnation. There were other programs like Sarma that were written by Everett Hook. Interestingly, in this time period, spreadsheets were around, but they were not widely used in engineering. And I think that had a lot to do with just software is very expensive. Through this time period, fax machines started to be introduced, and they really took off because people, could send borehole logs at the end of the day. You could fire them off to the office at night. So that was quite revolutionary. From 86 to 88, somewhere in there, I did my coursework for my graduate studies. I graduated in 89, but like a lot of people who do MEngs, you get out of class and you're back at work within 2 days or something like that. So I fell victim to that, and it took a while to get my project done. When I was at University U of A, again, there were a couple of IBM compatible personal computers around, but they were usually reserved for PhD students and researchers. Again, not trying to be chintzy, it was just they were very expensive. So all our master's coursework was done on the mainframe programs that had been around from the mid-70s. Your assignments that you did were all handwritten. You didn't have a computer to write things on, and there was lots and lots of hand calculations and everything from settlement and slope stability analyses. You'd obviously, you'd have to walk through these things. Not that we have a computer program. I'll just show you that again. But I don't know what university is exactly like today, but we did so many hand calculations for every method. This is Bishop's. We would do Yanbu. We would do this and that. So you really got to understand what was going on in the different limit equilibrium models. And there's the spreadsheet. Pardon me. There's the hand calculations that would back that up. But then you'd have to plug it into a mainframe computer. This one that does the Bishop calculation, I believe it was fortunate enough you could actually just separate your data with commas when you input it. The Yanbu one was certainly Fortran based, and you had to have everything in the correct column. If you had it off 1, you'd be out by a factor of 10 in your numbers. And just to notice here, so there's no graphical output. So first of all, you don't know, your problem isn't set up. You don't get to see where your soil layers are or anything. That's all up here. And then the output is basically, okay, here's your first failure surface. It's got an X and Y coordinate of that, and it's going to give you a factor of safety. So you have to go through it, plot it up, see if it makes any sense. So then when there's a period from about 88 to 95, I call this the small office years, and some of my colleagues will know what I'm talking about there. I left the bigger company, and I was in a group of about 4 engineers. And in this time period, we started to have our own personal computers, and we were actually writing bits of our reports. We didn't usually get them out the door. Again, we had a good typist that would format everything for us. And again, the software wasn't standard, mostly pre-Windows DOS. One of the interesting programs in the day was WordPerfect. And I say interesting because it probably hung on for a decade after everybody else was using Windows word processors. WordPerfect was just so good as a DOS program that it hung on for a long, long time. Spreadsheet use, now we started to use spreadsheet in engineering. And my favorite program in the era was something called As Easy As. It was a shareware program. And it was a game changer because of the cost differential between that and Lotus. So I wrote a lot of programs in As Easy As. And the joke being as easy as 1, 2, 3, right? In case that wasn't obvious. Through 1995 to 2000, that was an era where lots of travel, lots of helicopter work, and lots of things were changing technology as well. So the internet was more than a novelty. I mean, but it was still very painful to connect to. You'd have online services like CompuServe, AOL, all these dial-up things. CAD Vision, I thought that was revolutionary when it first came out. I mean, but you were limited to 8 characters. I think my handle was Sonder R because they put your last name, but they could only have 7 characters, and then your first name. So it was Sonder with 2 R's, no S on the end. So emails were slowly emerging into business communication. Cell phones were starting to become more the novelties as well through this time period, and that's mostly because networks were improving. Drafting through this time period, there's a hybrid between CAD work and manual with vellum and sticky tape and all kinds of stuff. It was whatever got the job done fastest was the preferred, and the reports are mostly non-digital. From 2005, I just thought steady as she goes because it's the advances in computer. You got to a point where computers were actually starting to work, and you weren't constantly fighting with you get new software and it won't run because there's not enough memory, and you were in this vicious cycle where you were never getting good performance. But we actually got to a point when Windows 2000 came out and NT, those are very stable platforms, and we actually got to a point where, hey, this is pretty good, it's working. Moore's law was still applicable to computers with memory growing exponentially. Through this time period, though, there's no new killer business applications. I mean, we had spreadsheets, we had word processors. There just wasn't anything really new that was on the market. Cell phone, the voice side of cell phones got better and more complete, like indicated with networks. We transitioned from the digital phone to the analog, and small businesses started to adopt servers and networks with real domains that you could log on to instead of previous that sort of the sneaker net or here's the floppy disk, pre-USB key for sure, but so networks became a thing. From 2005 to 2020, wow, I don't remember a whole bunch happening in big increments. It was just been a gradual, everything just got better. But I don't remember as many quantum shifts. For my GS program that I use a lot was Global Mapper, and I started off with version 6. I said it's 23.1. That's wrong. It's actually 24.1. This was interesting. Some of you in the room may remember when Google Earth first came out, and we had it on our computers, and I think we'd spend hours going to places like the Sahara Desert and just zooming in because it was just so amazing that what you could see, and a real game changer. And of course it's pretty integral to what we do every day. Is like everyone will say, send me a KMZ. So that's pretty standard. We eventually saw smartphones come in, so that was replacing the old flip phones. Your Motorola TAC phone were dead. iPhones came out in 2007, so to put some context in that. And we saw through this time period the gradual decline of land phone lines. So 2020 to present, the period I'm going to call COVID the disruptor, and it did push some technology though. So what happened is we had to quickly adopt and fix up or get rid of the bugs on remote communication software, Zoom, Teams, WebEx. They became very sophisticated and very stable in a very, very short period of time, and thank goodness, because I don't know how we would have got through the lockdown without those technologies. With everybody working remotely, there's obviously huge improvements to networks and security occurred through this time, all in the background, so kudos to our IT people for keeping us safe. But it has introduced a transformation of how we think about work and the workplace, and I think we're still grappling with that today. how much time do you have to spend in the office? Should it be none? Should it be all the time? Is it some hybrid situation? We're still working through this right now. So I said some of these technologies I just kind of wanted to focus in a little bit, and I'll go through these fairly quickly. I talked quite a bit about phones already, so I think I don't have to get into this too much. I think the landline in the office is dead. I think I lost my phone completely in 2020, but I hadn't probably used it for a good 5 to 10 years before that. I think the only thing we used it for was to page people. So we kind of missed that but I never got a call. People call me on my cell. No one calls me there. How we created reports, through this time period. So we saw a gradual transition from the purely bound paper reports that nothing digital went in there at all to now almost all reports are PDF. There's almost no hard copies of reports produced, and it's just for special cases, sometimes for hearings or legal cases. People want hard copies. Otherwise, everybody's electronic, and we just email things. Business couriers use has dropped off to almost non-existent, and it's really fortunate that we got a little thing like online and Amazon and stuff like that, because the couriers have just transformed from doing a lot of business movement to consumer products. And I guess the thing is, I think we are nearing the paperless office, but I doubt we'll ever get completely there. I still like every once in a while to print something off on paper because it's just easier to look at. Internet is a tool, so it hard to say when it really started, 69 to 83, something like that. But for most of us, I mean, it was the creation of the World Wide Web in 1990 that really started off so that we could actually had an address you could type in, and there was you can be redirected to the correct computer there. For my career, it probably became relevant around 1995, but now we can't imagine being without it. But it's linked to two other major technologies that make it work, and one of those is spatial positioning, and the other thing is is a smart device. So spatial is a theme that I've talked about quite a bit in the next few slides here, because I think it's probably, for me, it's been the biggest change in technology. That's the way I work. The internet also, of course, that's where we get all our news, commerce. We do our shopping online, or the great majority of it. We get traffic. We have social media that never existed, even 20 years ago. We do file storage on the internet, and we do data transfer. So things are tending to move towards cloud-based, and we were joking, I was on a bit of a rant here. Cloud-based just means that you're buying time on somebody else's computer. I'm not saying that's completely wrong, but it's not magical. It's just going back to the older model of somebody else has the computers, and you're doing the work on them, and they're selling you a service. We're just going full circle to what it used to be when it first started. So global navigation satellite system is sort of pivotal to all the spatial stuff. Basically started with Navstar in '73. We tend to refer to it as GPS, Global Positioning System, but that's really just military system. GNS is the more complete and correct thing. And up to it's been available in the 80s, but it was deliberately downgraded, the signals, so that you couldn't locate yourself up until about 2000. It was referred to as selective availability, and the theory was they were the U.S. military was concerned that bombs could hone in on the GPS signal and blow things up, and that they can do that anyways. So I guess they figured out that it wasn't that big a deal. Now it's integral to all our technology: phones, watches, tablets, cars. Consumer grade accuracy with the $10 chip in your Android tablet is probably accurate to 3 meters or to 10 meters, something like that. And it's been the cornerstone of what I call the spatial revolution. Photography, how we take pictures, completely has changed. We transitioned from film to digital sensors in probably 5 years. The transformation was almost complete. storage is really pivotal to that when you think about it. I mean, you can have thousands of images on a micro SD card versus 24 to 36 pictures on a roll of film. And really key to all this is it can be spatial. So we have the ability to georeference our photos either directly from the camera or your phone, or with post-processing techniques if you have a GPS track. And the last point here I think is quite interesting is smartphones have way better built-in cameras than the older mechanical point-and-shoot cameras that I'm very fond of. I have a little waterproof camera that I like because it's pretty bulletproof, and I thought I'll go get a spare just because I just like to have that technology. I don't like wrecking my phone when it's raining, things like that. It's almost impossible to buy a point-and-shoot. And the salesman at Best Buy, I think they said to me, it's like, why would you buy something like that? I mean, your phone is way better. And trying to explain to him, I'm trying to save my phone from all the mud and the rain. Yeah, he didn't get it, but that's okay. So I just want to kind of contrast with the technology, the way I would do like a helicopter reconnaissance, because this was a big part of the late 90s kind of thing when I did it like this, is to navigate. First of all, you'd have a marked up topo maps, 1 to 50,000 topo map. You'd have it all folded up nice and neat, and you'd have a line drawn on it, maybe even tape on there for the pipeline. And the way I would do this to keep track of things, so when I'm flying in alignment, I'd use a dictaphone, and I would call out. I'd take a look at my watch, call out the time, what the photo number is, and roll, and then some comment here like roll 2 slumping off north side of the right-of-way, and then the next time and the other feature. So, if you were just doing a straight recon, you could actually, afterwards, start to piece this together and figure out where you were, which was really valuable when you have, I would get out of the helicopter at the end of the day and I'd probably have a dozen rolls of film. I'd run to London Drugs and get them developed, and then you had to start to put, caption these things from your dictaphone. So a lot of post-processing, shall we say, afterwards. So now what do we do? Well, the first thing is you're going to email the helicopter pilot the route. Send me a KMZ. So the pilots in most cases will have this programmed. I said in the helicopter navigation that's technically incorrect. You can't use that system, but almost all the pilots have an iPad or something like that it'll be programmed into. All of us flying around are going to have some kind of a handheld tablet. We're going to have the alignment that we're flying. We're going to have various base maps, whether it's topographic, orthoimetry, hill shades, etc. We're going to know where we are spatially. And then we can add data. Just, okay, I'm here, boom, punch a button, add some comments in, and do it in real time. And everything is geo-referenced. So, more technology, more good things that have happened here. LiDAR. It's been around for quite a while, 1961. I think it started to come mainstream in my life about 15 years ago. It's widely available off the shelf, and it's really quite affordable for most cases. You can justify it. And it's really revolutionized terrain mapping and geohazard identification, because you can actually see the bare earth. So as I'm sure everyone in this room is very aware, this is what a hill shade of LiDAR, looking at some landslides up in the Peace River. And this paper to me, or this report, was quite revolutionary when it came out to me. It was a real eye-opener, and it was by William Burns and Madden. And they were doing some work in Oregon, which is, old growth forest, really heavily treed. And they, once they flew everything that they'd been doing with air photo interpretation for years, and they flew LiDAR for the first time in around 2007. And they estimated that they could see 300 to 200 times the number of landslides compared to conventional API. And when I read that the first time, I thought, wow, that's just amazing. So it really did revolutionize landslide mapping of older, especially of older features. Important to note, they still suggested that you do go back to look at historical air photos, and they suggested about 40 years old. And that's partly, and I'm going to talk about that a little bit more, it's to get a sense for activity. get a story here, because LiDAR is a snapshot in time. It doesn't give you, other than there are some things you can infer from activity by sharpness of features and things like that, but it is a static snapshot still. Drone technology. Well, drones are amazing. Like, first of all, just think about all the things that go into make a drone. There's the technology that goes into this, just stabilizing the flight. You don't really have to. The drone's going to hover when you take your hands off the control. That's amazing. It's handling the wind and all these other factors here. It's got sensors. It's got feedback loops. You can program them if you want to go where you want to. And how is this all possible? Many technologies coming together here. There's miniaturization of the electronics into this airborne platform. There's the whole idea of miniaturization of batteries, increasing of batteries. There's still a bit of an Achilles heel, 20-minute maybe flight time, but getting better. And that's all this concept of electronics has gone, like from tubes to transistors to chips. So, when we started, looking at this stuff, people couldn't fly a LiDAR capturing camera at the time, or there was one company that had a very large gasoline-powered, sort of a hybrid between a real helicopter and a drone, because the cameras were so big. Now they're getting smaller and smaller. They go on to a medium-sized to large-size drone. So it just continues. The technology gets smaller and smaller, and you can do more and more work. Of course, again, this is only possible if we can store the images on the machine. We've got software now that we can stitch the photos together. We can generate a DEM, and depending on whether you have survey control points or not, how accurate that DEM is, and I'm not a surveyor, don't pretend to be, but you can do some pretty amazing things. And just the ability to be able to fly this on any project, it's kind of revolutionized how we do inspections. And it's all about, again, because spatially we know where everything is. So this is, thanks to Damien, this is a pipeline in construction. This kind of shows you what kind of imagery you can collect there. We're just showing some things in oblique. You can use it for geohazard inspections. It gives you a really, very cost-effective way of getting a full picture that's very difficult to get when you're standing at the crest of a slope like this. And it's like 45 degrees, and you're saying, like, how am I going to get down there, or what am I even going to see when I get down there, because they're so big. So to tie all this together, you need some kind of a framework. And so if everything's spatial, it has to go into some kind of a spatial framework. So that's what a geographic information system is. And the interesting thing, GIS was basically started in Canada. Dr. Roger Tomlinson has been known as the father of GIS, and he worked for the Canadian government in the 60s. What goes into a GIS system? Yeah, it's more than software. First of all, you do need some decent hardware. The software, of course, there's many options. The big dogs are the Esri ones. AutoCAD is spatially aware now that it's getting better. I tend to use Global Mapper, and then there's open source, which I love, is with QGIS project. But hardware and software, I mean, this is so disappointing when you first do this and you say, okay, I want to use my GIS, and then if you don't have any data. So it only works and makes sense when you've got base maps. Either it's some imagery, you've got some geological maps, you got a legal fabric in there, and then of course your project data, where your boreholes are, where when you walked around in the field and you took some GPS points around some cracks or some headscarps or something like that. When you tie it all together, then you've got something that of value. And of course, with any good software, there's usually a steep learning curve, so training and skilled people are important. So I guess I embraced GIS around 2002, and I started to, as a hobby, databasing and georeferencing geology maps, and I still do that to this day. That's my hobby. I find a map, I got to georeference it and put it in my cache of public domain, or not public domain. Like government published maps and things like that. I guess I basically started off with an odd program called Aussie Explorer that was really developed by a guy in Australia, obviously, for navigation in the outback. But this program has some amazing abilities, and one that's most interesting is you can search your entire server, and it will tell you all the maps at a given point. It's pretty sophisticated for like a four-wheel driving navigation software. And then of course I said I use Global Mapper a lot. There's been big improvements in geophysics. Not surprisingly, the science or the physics remain relatively unchanged. You're just looking for contrast in material type, either density or conductivity or resistivity. But it has improved a lot. There's new methods to measure these different contrasts. Electrical resistivity tomography, or ERT, is one of those technologies that didn't exist maybe 15 years ago, and now it's one of our preferred for looking for gravel and depth of bedrock and things like that. Massive changes in electronic sensors and cabling, data collection, storage, and post-processing. Again, a lot of these require very sophisticated inversion models, especially with the seismic stuff, and again, more processing power, faster results. And your data is all collected spatially. I mean, you can run a GPR, drag it behind a quad or a snowmobile, and it's collecting breadcrumb, like peat thicknesses, just bing, 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 and all you have to do at the end is just dump it out. Cone penetration tests. So, it started off with the Dutch cone, but Fugaro first invented the electronic cone about 65. So it's been around a long, long time. It really is generally accepted as the de facto standard for investigation in soft and variable ground conditions, and it's really matured over years as again, computer processing, data storage, sensor technology improved. For me, though, I'm not a huge user of cone data, so it's hard for me to pinpoint a watershed moment when, it's arrived, it's mainstream. The reason I say that is because there still seems to be a resistance to use on small jobs, and I think the reason for that mostly is you got money to do one thing. You either drill a test hole or you can push a cone, but to do both, it seems to be a little bit prohibitively expensive. And so I think most engineers want to see the dirt, so they go for drilling holes. An oldie, but a goodie. Air photos. It was the technology really was developed between World War I and World War II. And what blows me away is we have stereo coverage even in Calgary from 1924. And you got to think about that for a second. I mean, we're talking about aircraft that's like, the Red Baron and Snoopy technology. I mean, these are biplanes, and we have stereo air photos from that era. We have the best coverage for all of Canada is between 49 and 51, and that's really because post World War II we had all these, veterans. They came back from the war. They could fly planes, but they were a little bit difficult to integrate back into society right away because the economy had changed. So there was a make-work project, for lack of a better word, but probably one that we benefited immensely from. So whoever thought of the idea of let's fly all of Canada was genius. So we've got a really good baseline for Canada around the 1950 range. So in the old days, we used to, have a contact print. This was literally printed off on photographic film. You'd view it with a nice stereoscopic thing like this. And why you want to look at it in stereo is because you can really, see landslides, you can see terrain, landform features, and it for many, many years was, especially before LiDAR, was the way you could do terrain mapping. So part of the sad thing, or maybe it's not that sad, but what happened about 10 years ago is they just phased out doing contact prints. And there was a period of time when we had something, we get laser prints. I don't want to talk about those because they were horrible. But we just don't have hard copies in general. But the argument that I hear a lot of people, even people that do terrain mapping said, well, it's redundant. I don't have to look at air photos. I disagree, and I think people like Lyndon Penner with Mollard Associates would argue that there's so many features like texture and color that tell you so much more. There's a richer picture than just looking at things in bare LiDAR. So and you've got a historical back to 4950, and then you can look at things through time, and hey, just looking at them, you can see when fill was placed, when this was dug out, when this hole was built. So there's a lot of value in air photos. So old technology, still a goodie. Through this time period, I mean, analytical software, well, it just keeps getting better. So, I mean, I don't, other than, you know, the big improvements were, in the old days, you used to have to, you know, put in every coordinate, give coordinates, and you wouldn't be able to see them. There was no, there was no plotting mechanism to set that. But you put in the coordinates for your points, then you'd have to tell it how to connect it to build your mesh, how the lines would go in, how, you know, are you using triangular elements? But you'd have to connect it to all the points. Incredibly prone to mistakes, and even more so when you couldn't see the results. So, yeah, that's what's happened to software. Now, it'll generate the mesh for you, and you see it instantly on the screen. So those are, I don't want to downplay that not much has changed, but it just progressed through time. And yeah, it's pretty good. Now we've got, the software integrates really well with the digital elevation model, i.e. LiDAR, way better outputs, and with bigger computers and everything, 3D is just a normal extension. So the future. So what I believe is there's a big lie, and throughout history we've been lied to that technology will make our lives easier, but it's based on the naive premise that if we spend 10 hours a day doing a specific task, and with technology you can do it in an hour, then you're going to have 9 extra hours to spend on leisure or culture pursuits. Well, that's not what happens. All you end up doing is doing more work. And part of that is self-induced. You yourself are probably going to do that. Your employer probably expects that, and your clients expect that. So I think it's a lie. I think, you know, we're not going to be sitting around on our hands. When we get a technological advance, we just do more. We do it maybe better. We do it more complete than we ever did before. The other interesting thing is, you know, like things like laptops, which I think we all transitioned to through COVID. You know, they didn't free us from the office. They just let us bring our work home. So it just gives you the opportunity to work more. So being a little bit tongue-in-cheek there, but they're not as freeing as we think. So where do I think we're going, or what do I think is kind of the key things? Is I think data, because there's so much of it, we got to get on top of it. So I'm just calling it data wrangling. I mean, the old adage, if knowledge is power, then spatial knowledge is even more power in my mind. We're going to have to really start thinking about databases, and no, Excel is not a database. We're going to really be putting things in some kind of a SQL database. They'll all be spatial. And you know, why would we want to do that? Well, part of it is, for me, is I'd like to save the next generation from reinventing the wheel, you know, making the same mistakes that I did or we did. You know, when I like to go back to like CGS papers. I love to go back in history, and I've been figuring out where these things were in these case histories, and it's really, or theses and things like that. And it's really fascinating. I was working on a landslide maybe 10 years ago, and it was only just recently I discovered that Robin Tweedy, one of our senior engineers in Edmonton, did his master's thesis on the Edgerton landslide, which turns out about a mile away from where I was. So had I only known, I'd have had, you know, we had the right interpretation, but boy, we had to get there the hard way, kind of thing. And I do see, you know, having to embrace some more data science technology to do that, either with R or Python or something like that. Training and learning. I think this is, you know, key for everybody. Be prepared and embrace a lifetime of learning. I think if you give up and say, yeah, I know enough, I don't need to really do that. If you do that too early in your career, you'll be left behind. So embrace it. You know, refusing to learn will reduce your opportunities and your longevity doing what we do, especially as a consulting engineer. Don't wait for your employer to initiate your training. Be curious. Look for, you know, find out an area that you're interested in, and then, you know, take some courses or talk to somebody. Whatever it takes, just, you know, just be interested and don't stop learning. My recommendation for people starting off in their career is not to specialize too early. This is really a hard thing because we all have to specialize because there's too much information not to specialize. But when you do, try to look at is this a good career decision and something you enjoy? Those are two really important things. So, will the technology be around 20 years from now? And or will I hate it if I'm doing this for 20 years? So those are important things to consider. Very briefly, I just want to touch on AI. So Alan Turing posed the question in 1950: do machines think? And I mean, we're grappling with that right now with all the AI is a real buzzword at the moment. Currently, it's not sentient. Okay, let's just get that out there. But what we have is massive amounts of data is being databased, and there's machine learning, and so machines are able to do pattern recognition really, really well. And what they do is they anticipate, okay, based on this, the next step or the conclusion is drawn from this based on what it's been trained to do and what it sees it has happened in the past. The technology is very, very good at assimilating and data connecting ideas. But the question is, can some kind of a chatbot write an engineering report, or can a bot write computer code? I think we're finding that it can. But what are the ethical, or how do you accredit? If a bot writes your paper, who gets the accreditation for that? And what are the professional implications? Those are just, I don't have answers, those are just questions. So I did fool around a little bit with some of these bots, and what I found is when I would ask them something very general, I'd be blown away by the response. I would get like a page or whatever I asked it, whatever length I asked it, of really good general information. Like, I mean, I asked something like, how do you stabilize a landslide? And darn, this was good. I mean, I was thinking to myself, I'm out of a job. This is too good. But then I started asking very specific things. Okay, how would you stabilize my 20-foot high, 26-degree slope in clay? And you start to see the cracks appear in the algorithms, especially when it always spits back your entire premise of question in the answer. Well, to stabilize your 20-foot high, 26-degree slope that's on this, it doesn't have a clue because it was too specific. So interesting. But if you are interested in the geotechnical world, this was kind of an experiment that Sanger and Moyer did, and they created some personas on ChatGPT for a geotechnical engineer at various stages in its career. And you can get that paper and have a look at it. It's a fascinating read. I mean, there's hits and there's misses, and it doesn't speak too much about the ethical implications. But it's I'm not saying it's tongue in cheek. But it's fun. It's a fun read. So I started thinking about this. Is AI good? I mean, is it a tool or is it an evil? So I thought, I'm just going to flow chart it up because I'm an engineer. So any kind of problem, we start off with some engineering inputs. And then we're going to run some kind of query on that, and we get some results. So really, you just test your results. I mean, you bound your problem. You put in, you put in the full bounds of your things. You put in data that you know, and then, so you verify the results. And if you can verify the results, then it's a tool, because it's not a lot different. None of us completely understand what's going on in a very sophisticated finite element model. Don't pretend that you do, because I'll call you out. But what you do is you bound it. You run known things. It gives me the right answer here, or it solves this well-known closed form solution. So if that's what's going on, then it's probably a good tool. If it's writing a Python script, but you get the right results out of it, then you've got some variability. Now, be cautious, but you know where I'm going with this. I mean, if you basically get an essay on something that you want to hand in for as an original thing, and you really don't know what it's saying, but it looks good, that's not a tool. You're in trouble right there. So, here's my major concerns with AI, and really kind of comes down to we can't verify the source of the information that the bot's using. And this is a requirement of engineering. We got to have metadata. That's really fundamental to our job. Because maybe it's not biased right now, but the concern is, will it get biased by politics? How about social agendas? How about unseen commercial interests? Like, what if this company has a slope stabilization widget and they're putting a lot of money into the database here? Then the first hit you're going to get out of the bot will be for this stabilization method, when it's really been influenced by a commercial insight. So call me a little paranoid, but these are the things that if you have no control over the data, you don't know where it's coming from, be curious, or not curious, but be discerning, I guess. And my last concern is, we might become overly reliant on bots for writing, and we lose a critical skill set. And the critical skill set is being able to write for oneself. And I just going to say that when I was very young, I used to be a big science fiction buff, and I read a short story about colonization on Mars. And the scenario was, Mars was being terraformed, they were creating an atmosphere, but it wasn't very oxygen rich at the time. So all the people that were mining on Mars were wearing some kind of a artificial breathing enhancement. And as it came down to, breathing was hard because the atmosphere is so thin, and so it was a struggle to breathe. But if you didn't breathe, you might lose the capacity to breathe and never make it back to Earth. So this is from Crucifixus Etium by Walter Miller in 1953. Breathing was unnecessary except to provide wind for talking, but Bennu breathed in desperate gulps of 4 psi Martian air, for he had seen the wasted and atrophied chests of men who had served 4 or 5 years, and he knew that when they returned to Earth, if ever, they would still need auxiliary oxygenator equipment. So, to me, that's just like writing. You can use the tool, you can rely on it heavily, but will you be able to breathe again? Or will you be able to write on your own when you don't have that tool? So, that's my concern on that. Real fast closing thoughts. If it hasn't been clear right now, technology is a tool that you've got to embrace it to stay current throughout your career. Don't let the technology run you. Don't adopt something just because it's trendy or sexy or something like that. Use it where it makes sense. Always remember that more complicated is not always better. Sometimes you don't have to run a very complicated limit equilibrium analysis. If you've got a friction angle of 25 degrees and your slope is at 35 degrees, you've got a problem. You don't need to run a model to show that. Do not completely abandon the older technology if it adds value. I'm not saying hang on to your slide rules and your old calculators, but if it adds value, don't just toss it out. And my best scenario, my best case for this is stereo air photos. Man, they're useful, and just the usage though in general has dropped off, and it makes me a little bit sad because I'm a geek for air photos. Don't forget to think. Older workflows, all those hand calculations we did in university, they made us just critically examine what we were doing. And particularly when we were writing reports, I indicated, the consequences of rework were significant. If it doesn't hurt as much, you want to think about what you're doing. If it's too easy, maybe you're not thinking about it. So just spend some time, read your reports. That's a pet peeve of mine. And I guess the parting thing here is something to the effect of, does technology make our lives easier or more complicated? And I'll let everyone decide that, because people have asked me, was it easier to be an engineer 40 years ago than now? And I frame it more like, and I can't tell you whether it's because I'm older and I'm just not a 20-year-old man anymore, but I feel life in general is more complicated. We're bombarded by so much information, and how many passwords do you guys have? I got hundreds. You got to have technology to manage your technology. So it's some food for thought. And anyways, I think that's it. Lana, thanks you. So.